Hello there. So in this demonstration, I'm going to show you some new networking and storage technologies that will combine with Windows Server and SMB3 to create an interesting storage solution. So to start, let's take a look at the two systems we have here. So on the left, we have IGE1, which is our server, and here on the right, we have IGE2, which is our SMB client. So we are going to start by taking a look at the configuration of our server, which is IGE1. So if you look at this PowerShell window over here, you can see that we have a storage pool that is comprised of 16 SATA SSD devices. So these are Micron SSDs, 800 gigs each. And we combined those into a pool, and we created a storage space out of that pool. So the goal here is that we're going to put workload on that storage space. So let's start a disk speed workload here. And you can see that my storage space is doing pretty well here. So we are doing a little over 120,000 64K IOPS. And the number I want to highlight here is that we're doing 8.3 gigabytes per second on the system, which is great. So each one of these 16 SSDs is rated between 400 and 500 megabytes a second. So this number here, 8.3 gigabytes a second, is a pretty good number for this storage subsystem. And notice also that we're doing this with only 3 millisecond latency, which is excellent as well. So now that you see what this is doing on the local system, let's stop this workload here, and we're going to look at it from the remote system. So this remote system, IGE2, is equipped with a 100 gigabit Ethernet Mellanox ConnectX-4 adapter. So that's a single port of 100 gigabits per second. And we're going to run that workload remotely using SMB3. So same pool and everything. And notice how interesting here, as we start running this workload, we see that I get the same 8.3 gigabytes a second. So I'm doing over 120,000 64K IOs per second. And more important, look at that latency. So again, we're doing this with around 3 millisecond latency, which is the average seconds per data request mark over there. Now, I have a little surprise for you here. So although I like this performance very much, wouldn't it be great if we could do a little better, right? So what we're going to do here is we're going to stop this workload. And we are going to go back to IGE1, and I'm going to show you that I have another pool here. So let me bring this PowerShell window up. Yeah, so there we have it. So we have a pool which is using some prototype Micron NVMe devices. So I have 3 of those SSDs connected through NVMe, which just means that we're connecting this directly to the PCIe bus on the machine. So we're going to make a pool out of these 3. And again, we're going to create a storage space. And we're going to put that same workload on it. Now, let me go back here to my PowerShell window, and we're going to start again running a very similar workload against this, and look at that number. So now against these 3 NVMe devices, we're doing much better than we were doing with the 16 SATA devices. So look at this amazing number. We're doing 11.2 gigabytes per second. And even more important, we're doing this with only 1 millisecond latency. So 170, over 170,000 64K IOs per second with 1 millisecond latency. And that's a whopping 11.2 gigabytes a second. Okay, so now I know what you're thinking. How about if we do this remotely? So let's stop this workload here and switch to EG2. And as we switch there, we're going to start the same workload, but this time remotely. So now the hope here is that we're going to put good workload here on this system. So you can see I am actually doing almost the same number, 11.1 gigabytes a second. So 170,000 64K IOs per second with, again, the very same latency. 1 millisecond. So this now I'm getting actually pretty close to the line rate of 100 gigabits per second here. And very impressive overall. This is remote storage that behaves exactly like local storage at a very high throughput. And look at the CPU utilization. We're actually using less than 20% CPU on both client and server. So what does this mean? It means that there's more left in those systems, over 80% CPU left for doing all kinds of other things that you could run at the same time that you're doing all this I/O. So again, nice demonstration of NVMe devices working with 100 gigabit Ethernet with SMB3 and SMB Direct.